Hi, grade 10s. Mr. McLeod here with our last lesson of the school year. And it's going to be on something called cosine law. Of course, we just did sine law, and today we're going to do cosine law. Okay, so to get into cosine law, we're going to start with a right triangle and talk about the Pythagorean Theorem again. So in the right triangle, we know that a squared plus b squared equals c squared. And you could picture a squared as being a square built on side A, and b squared being the area of this square built on side B, and these two areas equaling the total area of the square built on side C. So we're very familiar with that, but let's imagine doing something. Let's change this right angle. What I'm going to do is rotate this vertex in. I'm not going to change the lengths of A or B. So these areas are going to remain constant. But if I make this angle C smaller, what do you think happens to the length of this side and then consequently the area of this square? As I'm rotating this uh, side in, it is shrinking this side C and also making this area smaller. So again, here these two areas equal this area, and if all I do is make this angle smaller, so I rotate this arm in, it makes this square smaller and this area smaller. So these two areas no longer add up to this area. For these two areas to be equal, you'd have to subtract something from these two areas. So what I wanted to try to show you is, where does the missing area go as we shrink this square? Where does that missing area go? And here's the answer. I've created this triangle over here to show you. So it's roughly the same triangle. As I rotate this arm in, we get these two rectangles. So if I orientate these two triangles roughly the same way, let's see if I can do that here. Yeah. Then this here is the missing area. That's where that goes. So as this square shrinks, these rectangles get bigger and bigger, and that is actually the equal to the missing area. So again, if we wanted this a squared plus b squared to equal c squared, we would have to subtract a certain amount of area from a squared plus b squared. And the amount that we would have to subtract is exactly the area in these two rectangles. So all we have to do to fix Pythagorean theorem is to calculate how much area is in these two rectangles and subtract it from the a squared plus b squared. So let's see if we can figure out a way to calculate the area of these two rectangles. Okay, let's zoom in on what's happening here with this triangle and see if we can calculate the area of these two rectangles. These rectangles are the same size, so all we have to do is figure out the area of one rectangle and then multiply by 2. Okay, so of course the area of a rectangle is length times width. And the length of this rectangle is equal to this bottom side length of the triangle, which we've labeled as A. So the area is A, okay, times the width. Now what is the width? Let's just call this X for now. And notice that this width is the same as this distance here created by making a vertical line from the top vertex down to the bottom side. So this width is actually the same as this little distance here. All right, now we're kind of basing it all on this angle C. So we're trying to figure out this length of this side here, this X in the triangle, based on this angle C. And we know, or well, we might be given the length of this side, B. We know this side's called B anyway. And so this sets up a cosine ratio. So the cosine is this would be the adjacent side divided by the hypotenuse. So let me just do this down here. So cosine of C is equal to the adjacent side divided by the hypotenuse. And if we rearrange for x, put this side over 1. So x times 1 is x. And the other side is b cosine c. So this length, this width rather, of the rectangle I've called x. But having done this little calculation, we know that x is the same thing as b cos c. So what is this width? This width is actually b cosine c. And so we can put that in our little formula here. Area times b cosine c. And so our total area of these two rectangles would be 2 times this area. So total area is 2 times a and then times b cosine c. And this is the missing area by shrinking this angle c. If we shrink this angle c, it makes the c squared smaller. And so how much smaller does it get? It gets smaller by this amount, 2ab cosine c. So if we wanted to fix, if you will, the Pythagorean theorem, which we know well as c squared equals a squared plus b squared. And of course, that always applies in a right triangle. But as we make c smaller, the c squared gets smaller. So how much smaller does it get? It gets smaller by this amount. So to make this equation hold, we subtract 2ab cosine c. And this is what's known as cosine law. So you can think of cosine law as just being an adjustment to the Pythagorean theorem so that it holds in all triangles. Okay, we can come up with 3 forms of cosine law based on which side and which angle we're working with. Now, these formulas maybe look a little bit complicated, but let's just break them down simply and see if we can figure out a pattern. First off, the formula always kind of starts off like Pythagorean theorem. So a squared plus b squared, or a squared equals b squared plus c squared. We could start with b squared equals a squared plus c squared, and so on. And also notice that whatever side we start the formula off with is opposite the angle. So in cosine law, this is important too. And this will help you work with cosine law. Whatever angle, we're only working with one angle in cosine law ever. Whatever angle we're working with, we start the formula off with the opposite side. So same thing in this form here, cos b, we're working with angle b. And the formula starts off with side b, the square of side b, and then angle c and side c. And then the other letters that go in are just the other two sides. So b squared plus c squared, and then 2bc, a squared and c squared, and 2ac, and a squared and b squared, and 2ab. Okay, so let's put this to use, and I'll show you how to find a length of a missing side or a missing angle. Okay, find the measure of side C. We know one angle and these two sides. Now, I just want to point out, why do we need cosine laws? Because sine law doesn't work for every triangle. For example, in sine law, we would need a complete dumbbell. We need to know angle measure and the opposite side measure. But in this triangle, we don't. So sine law we can't use. So we must use this cosine law. Okay, so we know this one angle. We start the formula off with the side opposite. So in this case, it's c squared. So c squared equals the other two sides squared minus 2, whatever these two letters are here, 2ab cosine c. Okay, fill in what you know. So we know that a is 25 squared plus b is 17 squared minus 2 times 25 times 17 times cosine 55 degrees. Okay, now notice that you get, and this is always going to happen, 3 terms. So there's 25 squared plus 17 squared, and then minus 2 times 25 times 17 times cos 55. So this is all one big term. So what I like to do is evaluate each term separately. So 25 squared is 625 plus 17 squared is 289. And then just grab your calculator and make sure you punch in the negative too. This helps. Punch in the negative. Negative 2 times 25 times 17 times cos 55. Punch that all in your calculator and you will get a number 487.54. I would usually round to 2 decimals. Get 2 decimals there. All right. Now the next step is add these three numbers together, and you get 426.46. Okay, and just like working with Pythagorean Theorem, we always have to square root at the very end. So square root to get the length of our side C, which is about 20.7 centimeters. Okay, here's the next one, and I'll help you set it up. But if I think a good idea would be for you to pause the video, do the calculation on your own, and then check to see that you are correct. So find the measure of side x. What I want to show you here is that you don't necessarily have to write out that whole formula every time. All we have to remember is that we are starting off the formula with the side opposite the angle that we're working with, the given angle in this case. So we're going to start off this formula with x squared. So we start off with x squared equals 24 squared plus 19 squared minus 2 times 24 times 19 times cosine 43 degrees. Okay, go ahead and pause and do the calculation for yourself. We evaluate each term separately, and then we get 3 numbers that we just add up at the end. Okay, so we should get 16.4 meters. Okay, so that's using cosine law to find a missing side in a triangle. Next is using cosine law to find a missing angle. Okay, in this triangle, we're given the lengths of 3 sides, but no interior angles. So notice how sine law would not work in this case, because we would need a complete dumbbell. We would need at least one angle measure in there to create that complete dumbbell. But we're not given that in this case. We're only given the 3 sides. All right, what we want to do is find this angle. So we start the formula off with the side opposite. So we're going to start off with 21 squared equals the other 2 sides squared. I keep forgetting to use brackets here. 25 squared minus 2 times whatever these 2 sides are, 2 times 16 times 25. And then our missing angle is theta. Okay, so we want to solve for this cosine theta. Now, what I like to do is, since this term over here is a negative, what I like to do is first rearrange the formula to make that term I'm solving for positive. So I'm just going to switch. I'm going to move this term, take it over to this side. It's going to make this term positive. And then I'm also going to just move this term to the other side, which is going to make it negative. So moving it to the left, we get 2 times 16 times 25 cosine theta equals 16 squared 5 squared. And then if I move 21 squared to the other side, it makes it negative. I should have put it in brackets already. Okay, now evaluate what you can. So I'm going to go 2 times 16 times 25 equals 800 cos theta, and 16 squared is 256. 25 squared is 625. Then we have 21 squared, which is 441. Okay, this side we have 800 cos theta equals, we add these three numbers together, which is 440. Get cos theta by itself by dividing both sides by 800. All right. And just don't forget, we have to, when we divide this, we're going to get a long decimal number. But when you're finding the missing angle, you have to do that inverse cosine. So what I'm going to punch in my calculator is 440 divided by 800 equals, and I get about 0.55. But to find the angle, I'm going to hit second function cosine, and the angle I get is about 56 or 57 degrees. Okay, I got one more for you. Maybe this one would be a good one to pause the video and do the calculation yourself, just to practice doing that calculation. Find the measure of the smallest angle. Well, which angle is the smallest angle in the triangle, and how do we know? We might go off one of these, just the way it looks, but don't forget that the smallest angle is always opposite the smallest side. So we're given all three side lengths. 7 centimeters is the smallest side. So the smallest angle has to be this one over here. It's always opposite the smallest side. Okay, we set it up with the side opposite, starting off the formula with the side opposite. So I'll set up the formula for you. Pause the video, do the calculation yourself, and see if you get the same answer that I do. So we start off with the side opposite, which is 7 squared equals the other two sides squared. Okay, so hopefully we got the same answer, 33 degrees in this triangle. Okay, that's it for cosine law. Good luck, everyone, and let me know if there's you have any questions or anything I can help you with. All right, bye for now.